Hello everyone, welcome back to another session in our Basic Electrical and Electronics series. In today's video, we will learn about a very important topic in AC circuits, the power factor. Let's get started. In this session, we'll cover what is power and the types of power, the definition of power factor, causes of low power factor, ways to improve it, and the benefits of maintaining a high power factor. Let's begin with the basics. Power is the rate at which electrical energy is consumed or produced. It simply tells us how fast electrical work is being done. The basic formula is power is equal to voltage times current, and it is measured in watts. In AC circuits, we deal with three types of power. First, active power, P. Second, reactive power, Q. Third, apparent power, S. Let's understand them one by one. Active power is also known as real power or true power. It is the power that is actually consumed by electrical devices for doing useful work like lighting, heating, or running motors. It is measured in kilowatts or kW. The formula is P is equal to V times I times cos, where is the phase angle between voltage and current. Reactive power does not perform useful work, but it is needed to maintain voltage in the system. This power flows back and forth between the source and the load, especially in inductive loads like motors and transformers. It is measured in kilovoltamperes. Reactive or kVAR formula Q is equal to V times I times sin phi. Apparent power is the total power supplied by the source. It includes both active and reactive power. It is measured in kilovoltamperes or kVA. Formula S is equal to V times I. So remember, apparent power is what the system supplies, active power is what is used for useful work, and reactive power just supports the system operation. Now comes the main concept, power factor. Power factor is the ratio of active power to apparent power. Formula, power factor, PF, is equal to active power, kW, divided by apparent power, kVA, or simply, PF is equal to cos phi, where phi is the angle between the voltage and current waveforms. PF ranges from 0 to 1. A power factor of 1 is called unity power factor, and it is ideal. It tells us how efficiently electrical power is being used. There are many reasons why power factor becomes low. Inductive loads like motors and transformers, unloaded or lightly loaded motors, arc lamps, welding machines, and discharge lighting, poor system design or unbalanced loads, all these cause the current to lag behind the voltage, lowering the power factor. We can improve the power factor using a few simple methods. Install capacitor banks. They provide leading current to cancel lagging current. Use synchronous condensers. Add power factor correction devices or automatic controllers. Keep loads balanced and properly optimized. These techniques help maintain a high power factor in the system. Maintaining a high power factor has many benefits, reduces electricity bills by lowering demand charges, decreases power losses in cables and transformers, improves voltage regulation, allows use of smaller-sized transformers, generators, and cables, increases lifespan and performance of electrical equipment. It's one of the most effective ways to ensure energy efficiency. And that's all for today's session on power factor. We learned what power factor is and how to improve it for better system performance.